Greetings, Houdini Python students. This is Chris Rhoda. In this lesson, I will be giving a brief overview of using Python with Houdini expressions. And Python in this reference is used to replace HScript. Now, expressions are typically found in parameters or in parms, as we affectionately call them, and we'll be discussing the who.parm class in further detail in the near future. But most typical parameters are animated with keyframes. Most typical parameters that are animated with keyframes, or they are static. And while it is possible to manipulate the parameter expression while it is animating, doing so is a little bit gnarly. And we might be able to discuss this a little bit later in the Python animation class. However, for about 99% of the parameter situations, you'll probably want to delete the animated channel and recreate the parameter. Now you see this has got lots of keyframes on here to create all the animations. What we want to do is get rid of that. And you do that by going over to the channel, and you right-click on that bad guy and say delete channels. What that did was it deleted the entire keyframe channel for that, and now you're ready to start over from scratch. Now you can control the language of the parameters of your node by changing the language icon from the H in the HScript and move that over to the Python logo for the Python expressions. It is possible to mix languages for each of these parameters. However, we'll need to be discussing that a little bit later and in a different session. But once you've designated the language and you're ready to create an expression, simply type in the expression and you're ready to rock and roll. So for example, let's put a sine function here, sine frame. All right, and so this one is a very hyper excited sphere that's bouncing up and down. What I want to do is slow that bad boy down and make it behave a little bit more at ease here. So I'm going to go ahead and move that down. And so we have a, okay, it's now moving it's now animated very, very gradually. But I want to kind of go ahead and dampen the amplitude on that. So I'm going to put in a little amplitude dampener. So I'm going to go 10 divided by frame times sine. So what this should do is dampen the amplitude. All right, so we see here it's not very dramatic, but it starts off high and then it starts real low and then slows down. Now, as a good practice, even when not creating expressions in Python, is that when referencing the values of other channels, make sure to use relative paths instead of absolute paths. And to show you what I mean, I'm going to go ahead and modify the radius channel here of the Y, and what we have here is I'm going to access the translational value of its parent. That's why I have .. /ty. That means the translational value of its parent and not of its current value. And we see, uh-oh, it looks like we got a little bit of squash going on here. Okay, but in order to get some good squash and stretch, we're going to need some extra information on our two rad X and rad Z channels. So I'm going to add a little bit onto the rad X. And so basically, as the Y channel slows down, I'm going to compress the X channel. And we're going to do this. And basically, as the X channel moves, I want the Z channel to do the exact same thing. All right, so we should get some very cute squash and stretch here. All right, yes, very good. Squash and stretch. Yes, this flattens out. Very simple. Now, when doing multiple line expressions, you hit Alt-E to get into the multi-line editor. And in this case, I'm going to go and modify the rad X block. So I'm going to hit Alt-E, and that'll bring up a little Python editor. Now, I'm going to go ahead and type in a little Python block here. All right. There we go. That basically is doing more or less the same thing, but it's putting a limiter on the size of the radius of the Y. So if the radius of Y is less than 5, return 1. Otherwise, do the expression as we created before. And this is just a very simple expression. We're returning a new value. Accept. And we have our very cutely squash and stretch sphere. Very good. Very simple. Now, included with this lesson is an HScript Python equivalent reference sheet. Let me see if I can find it. Oh, here it is, which displays some of the commonly used functions in both Python and HScript. Use this if you ever get confused on how to translate or create a Python expression command. As we can see, we have all the HScript on one side and the Python scripts on another. Now, you may have noticed that I was not using the who in front of all the Python methods and the expressions. And you may have thought this was because I imported the who module in the Python RC script. However, this is not the case. While it is true that, while this is true, Houdini does automatically import the who module whenever it evaluates an expression. Now, you'll never need to use the who namespace while evaluating any Python expression. However, you will still need to declare the namespace for any other out-of-session modules, such as we did for the combo module. So to rehash what we discussed in this lesson, we covered a simple way to create a Python expression in any parameter, including deleting a pre-existing animated channels. Now, we showed how to convert an expression from HScript to Python and some very basic examples which covered relative references and multi-line expressions. All right, there we have our cutely animated sphere. Very cool. In the next lesson, we will be covering the structure of the who.node superclass. I'll see you next lesson.